Hello, students, and welcome to our math lesson today. And looks like we're continuing this week with our theme of pink. I hope you're enjoying that. Maybe we should have a class vote for what color we'll go with next week. Let me know if you have a preference. So today we're going to start talking about the parts of an expression. So we will start our lesson, as always, with our do now. And let's find a pretty color. How about this purple or blue? We're going to answer a prompt about being inclusive. We want to include everybody so everybody feels welcome. And that makes, when you feel included, you feel better. But when you are the person who is reaching out to make someone else feel inclusive, you still feel good about that. In fact, maybe you even feel better. Our objective today will be to learn about the parts of an expression and our essential question: what are expressions made of, and what separates the parts of an expression? This is a really important notion that you need to understand as you go into algebra. And there are two ways that my algebra students make mistakes. One is with the signs, and the other one is not understanding what separates the parts of an expression. So let's develop those good work habits now with understanding that. Make your life much easier when you go into algebra next year. So our assignment will be to answer our do now, which we do in class notebook. We'll watch our video. This video complete 2 pages today on expressions. I want you to answer your exit ticket and remember to show me your completed work as we're in our meeting. We'll get to our exit ticket later where we will remind ourselves what expressions are made up of and what terms are separated by. I remember I already mentioned that was important. So look out for that as we have our discussion on expressions today. If you did not get to finish all your work in class, that will be your homework, but we want you to do as much as you can and also show me whatever you've gotten done in class. You need to hold it up and show it to me. Thank you for that. Some of you are really doing a great job with that. So remember, camera on helps me get to know you and you get to know me. Respond when your name is called at the beginning, middle, and end of the period. Show your work on camera at the end of the period. If you're having trouble with your camera, let's get you another computer if that's needed, and I'll tell you how to do that. Or you can send a photo to me at that email right there. So let's get started with our do know. We have some important information. If you have not shown your work to the teacher, then the teacher must assume you have not done your work. So show your work to the teacher to get credit for your hard work. Be a superstar today in math. All right, let's get started with our do now. Lots of Valentines this week. So when everyone feels included, everyone feels safe and worthy. Worthy is what we all want to feel. Does having a safe and inclusive environment, so safe and inclusive, and we see the word include in there, right? We all know what that means. Does having a safe and inclusive environment help us learn better? When you're feeling better about the space that you're in, the people you're with, when you're feeling like you're an important part of a group, does that help you learn better? And I would even argue that turning our cameras on helps enhance that feeling of being in a group and being included. So something to think about. And I'd like you to write something right here about that. So we'll get back to our exit ticket later, but let's talk about expressions. Very exciting starting this new topic here in algebra. Oh my gosh, look what we have. There's a lot going on here. Let's just start by reading it. 14x plus 9 minus 2x plus 8 minus 5x plus 1. There is a lot going on. So let's talk about that. Okay, variable terms. The variable terms in this expression right here are the terms with a variable, which is a letter that represents a number. That's what a variable is. So in this expression that we have here, this long expression, I see a 14x. I see a negative 2x. And I see a negative 5x. Now, constant terms are terms without a variable. So in this expression, I see a 9, I see an 8, and I see a 1. Coefficients, that's something different. Those are numbers next to a variable. So let's think about this. We had terms with a variable. Now we're just talking about the coefficient. So 14x is a term with a variable, but the coefficient is 14. Negative 2x is a term with a variable, but the coefficient is negative 2. And negative 5x is a term with a variable, but the coefficient is negative 5. Okay, super important. What separates terms in an expression or equation? Well, if I look at this term, let's get our highlighter. Let's get our highlighter ready. And if I look at this big expression here, I see 1, 2, 3, 4, 5, 6 terms, which leads me to an all-important point. Terms are separated by addition and subtraction. Super, super important to understand. Super, super important to remember. This one concept is going to keep you out of trouble for the rest of the year and in the rest of your math career in high school. Knowing that terms are separated by addition and subtraction, let's count the number of terms in this expression. 1, 2, 3, 4, 5, 6. This expression has 6 terms. Okay, super important. And remember, we've got variable terms, constant terms, and in the variable terms, there may be coefficients. Now, if you have x all by itself, there is no coefficient. Okay, it's not until you have 2x, now we have a coefficient. So let's get on and let's see if we can identify the variable terms, the constant terms, and the coefficients in these next few problems we've got here. So number 1, the expression is 11a plus 4a. So the variable terms are 11a and 4a. I'm writing them with commas, separating them. There are no constant terms, and the coefficients are 11 and 4. In the second expression, 3x plus 6 plus 7x minus 4, the variable terms are 3x and 7x. The constant terms are 6 and negative 4. Now, I know what you're going to ask me. Is it a subtraction or is it a negative 4? Doesn't matter, students. They both operate the same way. They have the same effect on the outcome of an equation, and they have the same effect when you evaluate an expression. Okay? So it is a negative 4. We give this negative sign to the 4, okay? But it also operates like subtraction when we evaluate. You'll notice that we did not write the plus sign for the 6. I did not write positive 6, okay? But there is a plus sign in front of the 6. Generally, we do not put the plus sign if we have a list of numbers and it is the first one in a list, or even just a list of all positive numbers. So when you were, if you make a list of 1, 2, 3, you make a list of natural numbers, 4, you don't need to put the positive signs. But if those were integers and those were the negative numbers, you would need to put the negative. Okay, that's just the way we do things. All right, so let's keep going with number 2. Are there any coefficients? Well, we have the coefficient of 3 in front of the x, and we have the 7 in front of the x. So why don't you try the rest of these? We have 8 more of these, number 3 through 10. Give it a go yourself, and then, so pause the video, and then come back and let's see how you did. I'll have a sip of my coffee while you do that. Okay, students, how are we doing here? Let's move on. Let's see how you did with number 3 through 10. So number 3, the variable terms are negative 12m and 4m. The constant terms are negative 3 and 16. Those have no variables. And the coefficients are negative 12 and 4. And you'll see that these numbers are repeated twice because they are part of the variable term and they are also the coefficients. So number 4, the variable terms are 6k and k. And the constant terms are negative 4 and negative 2. So the coefficients are 6 and 1. Number 5, the variable terms are negative 5p and negative 2p. The constant terms are 3 and 13. And the coefficients are negative 5 and negative 2. For number 6, the variable terms are negative 10r. Then we also have a negative r and a negative 6r. Students, remember, in this negative r, we have an invisible 1. So there is only one constant in that expression, and it is 11. And then our coefficients are negative 10. Here's our invisible 1 in front of the negative r, and negative 6. Number 7, our variable terms, there's only one, negative 5, n. Our constant terms, there are 3, 19, negative 8, and 14. And so we only have one coefficient, and that's our negative 5. Number 8, our variable terms are 13y and negative 2y. Our constant terms are negative 5 and 18. And our variable terms are 13 and negative 2. And in number 9, we have 1, 2, 3, 4 variable terms. We have 8a, negative 7b, negative 2b, and 3a. Could hardly squeeze them in there. The only constant term we have is that 1, but our variable terms are 8, our coefficients, are 8, negative 7, negative 2, and 3. And finally, number 10, our variable terms are 11x, negative 4y, and 2x. And the only constant in that expression is 8. And our coefficients are 11, negative 4, and 2. So now that you know about the parts of an expression and you know about variable terms, constants, and coefficients, you can go on and learn the next thing we do to simplify an expression, which is to combine like terms. Sometimes I abbreviate it in my notes, CLT, combine like terms. So this means that you need to combine those common variable terms and common constant terms. You cannot combine like terms if they have a different variable. They're not like terms. So 2x plus 2y cannot be combined. You have to have everything be alike in order to combine the terms. So if we have an expression 14x plus 9 minus 2x plus 8 minus 5x plus 1, what can we combine? So we've got 14x, negative 2x, and negative 5x. So it would be 14 minus 2 minus 5. 14 minus 2 is 12, and 12 minus 5 is 7. These are like terms because they all have x. So when we combine those three terms, we have 7x. Now let's look at the constants. We have a 9, an 8, and a 1, and those are all positive. So 9 plus 8 plus 1, 9 plus 8 is 17, and 1 more is 18, positive 18. So 7x plus 18 is this expression, 14x plus 9 minus 2x plus 8 minus 5x plus 1 simplified. So now let's simplify some expressions. So first we have to decide, are they like terms? 4x plus 7x, they are like terms. 7 plus 4 is 11, 11x. Now we've got an invisible 1 here. 1k minus 6k, that's 1 minus 6, which is negative 5. So combining these, we have negative 5k. Number 13, we have 6c plus 11c. They can be combined. 6 plus 11 is 17c. And then we have this constant, which stays by itself. It cannot be combined with anything. In number 14, we have 7 plus 12, and 12 plus 7 is 19. We also have negative 2y. Negative 2y cannot be combined with anything, but the 12 and the 7 total 19. Now, let's think about the order in which I've written them. Generally, what we do is we put the terms with variables first, and the constants are last. And you'll see that when we did the 7x plus 18, that's what we did. So that's kind of the order that we write things in. As you get into algebra and you talk about more complicated polynomials, what we call them, you'll learn some other rules for how to write them. But for now, let's just remember, let's put the variables first, the constant last. And let's also say if we've got two variables, we put them in ABC order. So the variable toward the front of the alphabet will be first. Remember, you cannot combine unlike variables. So why don't you try 15 through, try 15 through 20 and come back to the video and see how you did, and then we'll do the rest. Okay, I'm going to work 15 through 20 now. So 11m minus 5m is 6m. And then we have this negative 13 that we cannot combine. Okay, negative 6 plus 8a minus 16. We cannot combine 8a with anything, so we write 8a, and we have negative 6 minus 16 is negative 22. Number 17, 9v plus 7 minus 3v plus minus v, and that's an invisible 1. We have an invisible 1 right there. So we can combine 9v minus 3v, which is 6v, minus 1 more v, which is 5v, and then we have our coefficient plus 7. Number 18, 4 minus 2n minus 3n minus 19. Well, let's combine negative 2n minus 3n, which gives us negative 5n. And then we have 4 minus 19, which is negative 15. Number 19, negative 14w plus 10w minus 11 plus 2w. So the 11 is all set because that is a constant which cannot be combined with anything. But we've got negative 14 plus 10. That's going to be negative 4. And negative 4 plus 2 is negative 2. So we have negative 2w minus 11. And number 20, negative 1 minus 6 minus 5r plus 13r. Well, we can combine negative 5r plus 13r, so that would be negative 5 plus 13, which will be 8r, because that equals 8. And then we have negative 1 minus 6, which is negative 7. Okay, so we've got 8 more problems left. Let's see if you can do some of these on your own. Why don't you try 21, 22, 23, and 24, and then come back to the video. Okay, number 21. I have 10 plus 4h minus 8h minus 1. So 4 minus 8 is negative 4h, and 10 minus 1 is 9. That's a positive 9. Number 22, I have negative 7x minus 12 minus x, and there's an invisible 1 here, plus 6x. And so we have negative 7 plus 1 plus 6. That's the same as negative 7 plus 7, which equals 0. So these cancel each other out. The x's go away, and now we have negative 12 minus 9, which equals negative 21. And that's the final answer there. So the x's went away. They were eliminated. Now in number 23, we've got x and y. So let's work with x first because it's earlier in the alphabet. Negative 8x plus 23x. So negative 8 plus 23 equals 15. So that's going to be 15x. Now I have negative 2y minus 6y. Negative 2 minus 6 is negative 8y. Number 24, we have an invisible 1 here. So we have negative 1a minus 5b plus 4b minus 11b plus 2 minus 3a. So let's start with the a terms. Negative 1 minus 3 is negative 4a. And let's start with the b terms. Negative 5 plus 4 is -1 minus 11 is -12. So that's -12b. And then we just have this one constant plus 2. Okay, ready to tackle some that are a little bit more challenging. So you can try them on your own, or we can work them together. So I have m and n terms here in number 25. 9m minus 5n plus 14 plus 1m, we have an invisible m, minus 2n minus 7. So 9 plus 1 is 10m. And then we have -5 n minus 2n. -5 minus 2 is -7n. Now we still have a couple of constants. We have positive 14 minus 7. Positive 14 minus 7 is positive 7. So that's our complete answer. In number 26, we have C and D, and we have one constant, -5. So I have 2C plus 7D minus 8C minus 1C minus 5 plus 4D. So let's look at the C's. 2 minus 8 is -6. Minus 1 is -7. So we have -7C. Let's work with D's. So we have 7 D's plus 4 D's. 7 plus 4 is 11 D's. And then we have our -5 at the end. Okay, let's look at the next one. We're adding unlike fractions, okay, with unlike denominators. So we need to convert 11/4 to eighths, right? So how do we get from 4 to 8? We multiply by 2, which means we multiply the denominator by 2. So we have 22 over 8k minus 3 over 8k. So 22 minus 3 is 19. And our denominator stays the same, and we just carry that variable through. So 22k minus 22 eighths k minus 3 eighths k is 19 eighths k. And you'll notice I'm not going to turn this into a mixed number. Generally in algebra we keep improper fractions. So it's a habit you'll get into. So what do we have in the next problem? We have 3/4. That's one term. Let's box in these terms. 3/4 is a term. -1/6v is a term. Positive 7/15 v is a term. And -1/2 is a term. So let's think about these denominators. We've got variable terms, -1/6v and positive 7/15 v. And then we've got terms that are constants. Let me get another color here, which would be the 3/4 minus 1/2. So let's convert a common denominator for the 3/4 and the 1/2. So a common denominator could be 4. So we will have 3/4, okay, minus 1/2. And if we multiply the numerator and denominator by 2, that would give us 2/4. Now let's take a look at the variable terms. Common denominator for -1/6v plus 7/15 v would be 30. So let's multiply both of these by 2. I'm going to do it over here on the left side of the page. Let's just look at those fractions. Negative 1/6 plus 7/15. We've decided our common denominator will be 30. So 15 times 2 is 30, and 7 times 2 is 14. 6 times 5 is 30, and 1 times 5 is 5. So that would be negative 5/30 plus, and that's v, 14/30 v. Now let's just deal with the constants, no variable. We have 3/4 minus 2/4 is 1/4, and that's a positive 1/4. We have negative 5/30 plus 14/30, which will equal negative 5 plus 14, which is 9/30. So, and that's our variable term. Now, still not done. We can simplify 9/30. So 9/30, 9 divided by 3 is 3. 30 divided by 3 is 10. Again, this is our variable term. So I'm going to put that in the front, and we still have this positive 1/4. And that's our final answer. So this was a really tricky problem. We had to convert our denominators to like denominators. We had to remember to put our variable term in the front. We had to remember to evaluate constant terms separately from variable terms. These are the variable terms. And then we had to write our answer in reduced fraction with the variable term first. So if you were able to do that and follow along, great job for you. Let's go back to our exit ticket. Expressions are made up of what? So there's 3 things. They're made up of variable terms, they're made up of constant terms, and coefficients. Terms are separated by, remember I said I really want you to remember this. Terms are separated by addition and subtraction. So 6x is one term. 6 plus x is 2 terms. Okay? You've worked very hard today. I hope you enjoyed our hearts. We'll do that for a couple more days. Thank you for all your hard work. Don't forget to show me what you've done before the end of the period. Keep working hard, keep practicing, because you know the drill. As you do, you'll be great.